don't have any kind of scheduled job service, and there's no immediate term plans to add that.
Fleet does have some sort of cron style jobs internally, but those are solely for the purpose of kind of managing Fleet's internal state and resources and doing some cleanup of things that exist in the database that need to be checked and expired on certain intervals.
And as of today, they run on all of the computes, right?
They run on all the computes right now, and the jobs are idempotent, so it doesn't matter that they're running on all of them, and they're also relatively cheap operations to run. I mean, definitely something that's coming will be some form of leader designation, so that only a single one of the Fleet servers will be running these kind of jobs, and then we'll be able to, this will probably come along with jobs that start to be more heavyweight, such that it actually motivates wanting to do that kind of thing.
Got it. And in the meantime, hey, anarchy in the UK. So, okay, so then that brings us now, I can't think of any other things other than talking about how this data flows between our queries. So maybe we start, because I know it's different for live queries and scheduled queries, and I know Redis is kind of at the heart of all of this. Before we get into the Redis side of it, should we talk? I think there might be some WebSockets.
Yeah, so the WebSockets are used for pushing live query results down to the user clients. And when I say user clients, I'm making a distinction between OS query agent clients and user as in human consumer of the data that's generated by Fleet.
Got it. So that's going to be either, me, I'm Sarah in in the SOC, like running Fleet control, or in my house, whatever, which is Fleet CTL, right? Like the command line tool for Fleet to run, basically to exercise the Fleet API in various ways. Or I am in the web browser in the Fleet UI, and in both of those cases, I would have a WebSocket connection potentially to the Fleet server. And when we say to the Fleet server, we're talking about really to one specific Fleet compute, right? Because we're not using sticky sessions at the load balancer.
Right. Yeah. So typically, besides for these narrow instances in live query where we use WebSockets, everything is completely stateless, and so the load balancer can round robin or however it wants to distribute the requests. It doesn't matter much, and all of the state that is needed is accessible through MySQL and through Redis. And you're right that the case that the state does matter is the one where we maintain this persistent connection and we're trying to push down results to a single client that are coming in from many different agent clients. So they're coming in from many different OS query clients, potentially hitting a variety of the different Fleet servers that are sitting behind this load balancer, but we need only one web browser or one Fleet control API client to be receiving all of those results that are fanning in from all of those different agent clients.
Got it. So if this is I got the Fleet control command line tool or the web browser, and then it's making a WebSocket connection only for live queries, right? Only to get and receive live query results, and it's making that connection to Fleet, which a detail of that happens to be it goes to one compute, but it doesn't really matter that much because it's only going to be live long enough for that compute to go talk to all of these agents and then get those results and WebSocket them back, and then that WebSocket connection is effectively done.
Yeah, and to be clear, that one compute has no ability to talk to the agents. This is where we kind of have to step back to the model that OS Query uses. OS Query is often operating on endpoints where IP addresses are dynamic, where firewall rules and that kind of thing would prevent getting inbound access to OS Query running on those hosts. So all of the network communications from OS Query are initiated from OS Query to the server. So when we think about this problem of the fan-in of live query results that needs to get down to a single user client, it's coming in from all these agent clients. The agent clients are connecting to an arbitrary fleet server sitting behind the load balancer. It's not necessarily the fleet server that is connected with the WebSocket to the user. And this is where Redis comes in again. So then,
real quick, Zach, just to make sure I synthesize this correctly. So, putting on my Node.js guy hat, like I'm thinking, like, oh, okay, it's like Socket.io. Like we're doing a WebSocket between fleet control and the browser and then the server. But meanwhile, there's this illusion of a persistent connection between all of our agents and the fleet cluster. But that illusion is actually provided by this like polling-y mechanism.
Correct. Yeah. Yes, there is. I think it is definitely correct to say there is an illusion of a persistent connection. Really, it is a polling type of model that the agents use, but it's certainly. Sorry.
That's HTTP, right?
Yes. Yeah. And it's physically HTTPS. Yeah. And OS query refuses to communicate over. An insecure channel for reasons of helping people not shoot themselves in the foot with potentially exposing sensitive data.
Got it.
So this illusion of the persistent connection is maintained, and Redis is used. The pub subsystem in Redis is used to fan in the results coming from all of the different fleet servers, from all the different OS query agents connecting to all of the different fleet servers. The results get pushed into the Redis pub sub, and then they're pulled from the pub sub by the one fleet server that is maintaining the WebSocket connection to the user client. And so that's how the user client is able to behave as though it actually has persistent connections to all of the different agent clients.
Got it. And somehow the WebSocket backend knows when this collection is complete. Yeah,
well, essentially there's a couple of different ways when we know it's complete. One would be if we see that every expected host has actually returned results, then we just close things down and say, well, we're done because we've completed the work. And then the other would be that it just looks out for whether the user client is still waiting for results. Because if you're in the Fleet UI, you can hit the stop button, you can navigate away from the page. And if you're in Fleet Control, you can hit Control C, or maybe someone just pulled the plug on your desktop computer. And in any case, somehow that connection closes, and then Fleet in the background essentially detects there's no longer anyone listening for the results of these queries that are coming in, and then it says, okay, stop sending this query out to any agent clients because no one's listening for the results.
Got it. And then dump any of these live query results we've been holding on to, or let them free them up, and all good. Everything's all clean. So if I drive under a bridge when I'm talking to Fleet from my phone, if I'm lucky enough to be able to get our UI to work on mobile right now, because it's mostly pretty desktop focused, that'll change eventually. But if I unplug my desktop computer, I lose internet connectivity. It's not like Fleet's going to get all gummed up and crash. Like it can heal from that and no problem.
Yeah, it heals from that, and as of now. Like we've said, there's no storage of scheduled query results in Fleet. There's also no storage of live query results in Fleet. The results just flow through Fleet to the client, again, the Fleet Control or the Web UI client. And so if you lose that connectivity, you don't lose the results that you've already got, but you just cease to receive new results, and the client cease to do the work to generate the results. So the work just stopped happening. If there are clients that you still need results from, right now, you just run a new live query and you start getting the results again.
Got it. And
typically,
right.
Sorry?
Right. Clients means agents, right? Here?
Sorry, yes, agent clients.
Got it.
Yes. And again, typically these agent clients are configured to check in every 10, 30, 60 seconds. So usually you know, if your hosts are online, if a substantial proportion of your hosts are online, then usually you have 90% of your results within, 10, 30, 60 seconds. We obviously can't get results from hosts that are offline in the case of live queries. In the case of scheduled queries, this is different because hosts are running results even when they're offline, have no connectivity. Obviously not if the computer is turned off, but if the computer is on and the queries are running, they buffer up the results and they write those results to Fleet later. For live queries,
OS query, right? That buffering.
Right, exactly. OS query buffers those results, and within OS query, and if you're an operations person thinking like this is an issue because now we could have OS query filling up the disk and with an infinitely growing buffer of these kind of results, this is also by default limited within OS query how much it can buffer, and it starts purging older logs and that sort of thing. This is all configurable as well within OS query.
Got it. And we got like 2 more minutes, so I think we'll see if we can get all the schedule query stuff. I think we can do it. So like this buffering is only for schedule queries or only for live queries? Just to make sure I got it straight.
Yeah, so the buffering is only for scheduled queries. The liveness of the live queries means that there must be an ability for the agent to connect to the server to retrieve the work requested, right? The point of the scheduled query is that the queries are retrieved when the agent checks in for its configuration with the server, and along with this are intervals that the queries are requested to run on, and then those queries just continue running on the requested intervals, and also doing additional OS query kind of features like generating the differential logs of how the query state is changing over time. So it's not just a point in time snapshot like what a live query is, but it's those diffs and everything, and that's all of the data that is persisted locally until the Fleet server is back accessible. One other thing to point out in that context is that when we think about the Fleet server being inaccessible, there are a number of reasons why this could be. It could be because the agent is offline, like the host is no longer connected to Wi-Fi or the network's down or whatever. It could be that Fleet server is down for maintenance, network partition, any of these kind of things. But it means that when the Fleet server comes back up, we're able to ingest all of the events and the logs that took place while the Fleet server was down.
And there's some smart stuff for the thundering herd problem that you've mentioned before too. So I think would it be right to say that schedule queries also, the agent, OS query agent, talks over HTTPS to send that to Fleet. Fleet gets it and ships it off to the log destination. Just normal HTTP or receive the request and then send another request, or however it talks to the log destination.
Correct.
Awesome, man. This is great. Thank you so much, Zach. I learned a lot.
Yeah, for sure. Thanks for the questions.